Hi, let's continue with Chapter 4, Discrete Probability Distributions. Let's begin with Section 4.1. Let's read some definitions. Definition 1. A random variable x represents a value associated with each outcome of a probability experiment. Next definition, a random variable is discrete when it has a finite or countable number of possible outcomes that can be listed. So an example would be like 0, 1, 2, 3, and 4. It's finite and it's countable. A random variable is continuous when it has an uncountable number of possible outcomes represented by an interval on the number line. Definition: a discrete probability distribution lists each possible value the variable can assume. Together with this probability, a discrete probability distribution must satisfy these conditions. So we learned this from a previous section when we worked with probability distributions, and we saw the two things that need to happen is the sum of all your probabilities. It needs to equal 1 or 1.0. It needs to be exactly 1. This is if we're in decimal form. If we're in percents, this would be equivalent to 100%. Also, each probability needs to be between 0 and 1. And what this means is that there's no negative probability, there's no probability bigger than 1. It has to be strictly between 0 and 1. And every decimal in between is fair game. Constructing a discrete probability distribution. 1. Make a frequency distribution for the possible outcomes. So it would be a chart where some number or some value and the probability of it. Find the sum of the frequency. Make sure they add up to 1 or 100%. Find the probability of each possible outcome by dividing its frequency by the sum of frequencies. And 4, check each probability is between 0 and 1 inclusive and that the sum of all the probabilities is 1. Let's do an example. An industrial psychologist administered a personality inventory test for passive-aggressive traits for 150 employees. Each individual was given a whole number scored between 1 to 5, where 1 is extremely passive and 5 is extremely passive-aggressive. A score of 3 indicates neither trait. The results are shown at the bottom. Construct a probability distribution for the random variable x, then graph the distribution using a histogram. All right, so we have a score and a frequency. Now our hopes are to build a chart where I have these scores, 1 through 5, and I want to attach a probability to each one. Now according to our instruction, I need to start off by finding the sum so that I can find the relative frequency. All right, so if we add 24, 33, 42, 30, and 21, we get a total sum of 150. All right, to find the probability of each frequency, we have to use a calculator. So we're going to work and calculate 24 divided by 150. And that gives us 0.16. So for the score of 1, has a probability of 0.16. Next, I have 33 divided by 150, and that gives us a probability of 0.22. So we go ahead and attach 0.22 to the score of 2, and so on. So 42 out of 150, get 0.28. 30 out of 150, we get 0.20. And 21 out of 150, we get 0.14. Now, when you're doing these, you're going to use a calculator. It won't happen as quick. I have all the the answers in front of me. So I took the time to use my calculator, punch it in. So there we have our chart. Now, this problem was also asking for a histogram. All right, well, we can use our probabilities to build a histogram. Let's go ahead and make our score our x-axis and our frequency, or relative frequency, or probability, the y-axis. Now, our highest value has to be 1, right? And let's go by 2s. So 0.20, 0.30, 0.40, 0.50, 0.5. And we have these values. All right. So for 1, we have 0.16. So maybe a bit more than the halfway mark. For 2, we have 0.22, a bit more than 22. I think you get the idea. You can go ahead and finish your histogram. All right, that's that example. Next example, verify that the distribution for the 3-day forecast and number of days of rain is a probability distribution. All right, well, to verify, I need 2 rules. Did you recall those 2 rules from the very beginning? All right, one of them is that the sum of all my numbers, of all my probabilities, is equal to 1. If it's not 1, if it's over 1, it's not okay. It needs to be exactly 1. Now, if you take the time to punch this in your calculator, you see that, yeah, it works out. I get 1 as a sum. Cool. That's one of my rules. Next rule is each one of my probabilities needs to be between 0 and 1. And what I mean between 0 and 1 is it can't be negative. That wouldn't be between 0 and 1. And it can't go over 1. And when I think of that, I always think of blackjack. Once you go over 21, then it doesn't work out, right? So we see that all of these values are decimals, but they're not negatives, and they don't go over 1. We don't have a 1 point, blah, 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 right? So then we can say, yes, we know that is a probability distribution. And it's because all of my sums add up to 1, and because all of my numbers our probabilities are between 0 and 1. So it checks out. All right. Now we can also find a mean and a standard deviation for a probability distribution. All right. These are formulas. Now, if you're using Excel, these formulas might be handy. I put a video up on our Canvas that shows you how to work your way around it. I also put a video using a calculator, so whichever one you're using. These are our rules for a variance, which is just our standard deviation squared, and a standard deviation, which is the square root of our variance. We also have a mean, and it's each value multiplied by the probability. Now, if I may add, I think this could use some parentheses. So make sure you multiply them first, your x and your p, then you add. Let's do an example. Based on the last example, what is the mean, variance, and standard deviation of the probability? All right, well, let's take a look at our last example. We had days of rain and probability. All right, let's start doing it by hand just so you can appreciate your technology. So we had x was between 0, 1, 2, and 3. And I'm just copying down the chart above. And P of x, probability of rain, was for 0, 0.216, 0.432, 0.288, and 0.064. All right, if I'm following my formulas above, To find the average, I need to multiply each x value by its probability. So let's take the time to find x times p. And then at the end, I want to add them. All right, so I have 0 times 0.216. Anything times 0 is 0. 1 times 0.432. That's just itself. And 2 times 0.288. And we use a calculator, and they'll give us 0.576. And 3 times 0.6064, and we get 0.192. All right, then we wish to add these outcomes. Once we add them, we get a number, and that is our mean. Our mean is 1.2. All right, now to find the standard deviation, it's a bit more complex, but we can still figure it out. I'll set you up for it, and I'll let you finish on your own. Or you should just go ahead and look at your text. They have all this worked out for you. All right, our rule to get us ready for standard deviation, we have x minus our mean mu squared times your probability p of x. So that's x minus your mean squared times your probability. All right, so our value x, these are your x's, right? And that's your p. And this right here is our mean. So that first one we'll read x, which is 0, minus our mean, 1.2. You're going to want to square that and multiply it by your probability, which is 0.126. Next one will be 1 minus 1.2 squared times 0.432. And from there, we want to add them to get our variance and take the square root of our answer to find our standard deviation. Again, you can use Excel or a TI-84. If you're using a calculator, it would be the same way as you did grouped means to work with grouped values. So you would make two lists. This would be your list 1, and this would be your list 2. And then when you do one of our stats, you bring up L1, comma, L2. And there's a video of that too. You can use Excel, but for Excel, you kind of have to remember or have the formula handy. Whichever one you choose, it's great. But for these problems, I kind of choose calculator. All right. We can also find the mean for an expected value. This are the problems you want to think about when you're probability of winning something, right? So it's an example that does just that. Let's first highlight our formula. Our expected value is like our mean. Okay, let's see this example. At a raffle, 1,500 tickets are sold at $2 each for 4 prizes of 500, 250, 150, and 75. You buy one ticket. Find the expected value and interpret its meaning. All right. So let's make a chart of our probabilities. Let's use our x and our p of x. So x and p of x. Now let's consider let's break down our portions or our places. I can win first place, which would be $500, right? I can also win second, third, fourth, and I can lose. So let's set that up. We can win second place and win $250. Third place, $150, and fourth place, $75. Or I can lose, right? Or that would be everything else. however you like to think about it. That's every other option. So here we have all of our options set up. Now let's figure out our x, our number in dollars. How many dollars are we winning? That's what we want to consider. Now, whether you win or lose, you still have to consider those initial $2 you used to buy your ticket. So if you win first place, we would have to figure out 500 minus the $2 you put as an investment. So your x would be 498, 500 minus 2. Second place, we went to 50 minus those $2 you invested. You would win 248. 150 minus those $2 you invested, 148. And $75 minus those $2, 73. Now what if you lose? You didn't win anything, but you still paid those $2, right? So that's a -2. Now we can have a negative for x, but not for our probability. Now our probability would be a fraction, right? Or total over our part. So part over total. Only one person can win first place out of 1,500. Only one person can win second place out of 1,500. Only one person can win third place out of 1,500. And only one person can win fourth place out of 1,500. All right, what's left? Out of these 1,500 people, how many lost? Well, let's think about it. 1 first, 1 second, third, and fourth. So we have 4 people who did not lose. So 1,500 minus 4, our numerator would be 496. Again, that number 496, I wrote the wrong number, is from 1,500 minus 4, the 4 that won. Okay, now we're going to find the mean. It's the same thing as the mean. So remember like the problem we did before? Our second example, we're going to multiply each number by its x, each probability its x, and then add it. So let's go ahead and do that. So we have 498 times 1 over 1,500 plus 298 times 1 over 1,500 plus, that's our second one. Our third one, we have 148 times 1 over 1,500 plus 73 times 1 over 1,500 plus -2 times 1496 6 over 1,500. All right, that takes a bit of calculator work. Now remember, you can multiply your fractions across in case you want to punch it in together at once. So this would be 498 over 1,500. And then you can put this in parentheses before you add and continue. Your answer would be -1.35. So on average, right, because our expected value in a sense is our average, on average, people lost $1.35. All right, let's continue with our next section, binomial distribution. Let's begin with definition. An experiment is a binomial experiment if the following all hold. A, the experiment is performed a fixed number of times. Each repetition is called a trial. B, the trials are independent. One trial will not affect the probability of another trial. C, for each trial, there are 2 mutually exclusive disjoint outcomes, success or failure. The probability of success is the same for every trial. All right, so we're introducing new variables, and our symbols are N, P, Q, and X. For N, it's the number of trials. P is the probability of success in a single trial. So this would be your percent. Look for your percent. Remember to change it to a decimal by moving it to the left 2 places. And n, I think of n as your total number given, your whole group. Your q is 1 minus your p. So this would be like the complement. And x is the number you're being asked to work with, right? It's going to be a whole number. So 1, or starting with 0, 0 is a probability up to whatever number your n is. All right, we have a crazy formula and why we spent so much time with factorials back in our last chapter. So here's our formula. For a binomial experiment, the probability of x successes in n trials is n choose x with your probability raised to the x power times your complement with the exponent of n minus x. Okay, please don't use your calculator. I'm sorry, please do not use this formula. It's beautiful and you can do it, but it can become quite messy. Use your technology. All right, so if you're using a calculator, I will post a video on this. We're going to press second bars and choose binomial PDF, and that's how you can use the formula above. You can also do cumulative, meaning it adds them from 0 up to whatever x you want to work with, and that would be binomial CDF. So notice the C and the P, that's the only difference. Every other letter in that phrase is the same. Now, using Excel, there's different ways you can think about it. I put a video and it makes you figure out all of the values together, and that's fine. Or if you really want one particular value, you do binom.dist and you put the x value followed by the n and then p, and then you do false. You do false because this would be the single value. So this would be similar to binom PDF. So it's for a single x value. Now, if you want to find more than one probability, you can always find them and then just add up those cells. Let's do an example. According to CTIA, 41% of all U.S. households are wireless-only households, no landline. In a random sample of 20 households, what is that probability? Now, something we missed out on is if we were in class, I would ask you, hey, how many of you have a landline? And as years have passed, I see that less and less students have the landline. So even though we have these texts and they're updated and there's new additions, within these years, the numbers have changed. So A, find the probability that exactly 5. So this would be when Excel, when you enter false, and in your calculator, if you choose to do a calculator, this is when you would do the P option, binom PDF, meaning a single value. For the sake of appreciating your technology, I will do this by hand, but please do not do this by hand. I want to know when x is equal to 5, or you can do p parentheses x. Okay, so this would be, let's write down our formula and choose x of p raised to the x power of 1 minus p and minus x. So this would be 20, that's our n. Choose 5. Our probability, which is 41%, so 0.41 raised to the x power, 5. 1 minus 0.41 raised to the n minus x, 20 minus 5. Now, something I always like to do with these problems, and I fail to do at this point, is label your values, n, p, x, and if you want to, you don't have to, because you're using technology, you won't need this, but if you want to, you can always label your q. But technology does not require the q. Our n is our total. We have 20 people in this sample, right? Our P is always your percent. So 41%, our probability is 0.41. And X, that's the number that's going to vary for each one of these questions. That will be your X. All right, so if you're interested in a calculator, 20 choose 5. This is the calculator command. It's a really big number. 15,504. 0.41 raised to the fifth power is 0.0116, and 1 minus 0.41, that's 0.59 raised to the 15th power. Use any calculator, and it's a really small number. It's 0.000365. You multiply them, and your probability is 0.65. So the probability of having exactly 5 out of 20 who have a landline is 0.65. So not very likely. All right, that was A. Please use user technology. Don't do this by hand. If you do not like Excel, use a graphing calculator. You don't have to buy one. Like I said, you can always use an app that works like a graphing calculator. Just make sure you know how to use it. It should work the same. B, fewer than 3. These phrases always get me confused. I will add a page that I really like that helps you deal with this wording, but you can always think about it, and it makes more sense if you think about it as money. So if you had a budget, you have to spend less than your budget, right? So fewer than 3 would mean less than 3. But what does that mean? Now, when we're looking at these probability distributions, we have to consider the probability of not getting any. So this would be a probability of 0 plus a probability of 1 plus a probability of 2. This is the commutative option. So if you're using a calculator, you would use binom CDF, and when you enter your calculator, you need 3 pieces. You need your N, your P, and whatever number you want to stop at. So in this case, it would be 2. So our N is 20, our P is 0.41, and our X is 2. So this would give us 0.0028. All right. I know it's hard to follow since I'm just writing commands, but what I really want to focus is this wording. This fewer than at least is very confusing to some. If it's not to you, then forget I mentioned that phrase. All right, C. At least 3 are wireless only. So this means that 3 is our smallest number, at least. So the number it wants is a probability of 3, probability of 4, and every single probability up to 20. Now, this is where technology is really nice because otherwise I'll be stuck doing a situation like A 17, 18 times, right? It's a lot of work. But using the cumulative command, we can do this all at once. Or you can be clever, right? We see that above, we found the complement. We found 0 through 2. And here you want the rest, the remainder, 3 to 20. So if I have my answer of 0.0028, and if I want the other remainder of it, I can do the complement. So I can do 1 minus 0.0028. I didn't have to do any extra calculations. 0.0, if we subtract, we get, oh, I didn't figure that out. Now I have a calculator with me handy. So you can go ahead and figure this out. Our next example. According to the Gallup organization, 65% of adults are in favor of the death penalty for individuals convicted of murder. In a random sample of 15 adult Americans, what is the probability that exactly 10 are in favor of the death penalty? No more than 6 are in favor of the death penalty. All right, before we begin, let's figure out our N, our P, and our X. N, our P, and X, and that will vary by question. But that's the task at hand. N is your total random sample of 15 Americans. N is 15. Our percent, 0.65. Okay, let's go ahead and find out exactly 10. All right, so if you're using your calculator, For A, we would do binom PDF, our total, 15. That's your P. And you don't have to put that value in the bottom. I'm just helping you out. So it'd be 15, then our percent, 0.65, and then whatever number you want. So 10. Now again, that's P, no, that's NP. Already messing up. So that first number is your N, that second number is your P, and that would be your X. And your answer is 0.2123. Now we're using Excel, the same numbers but different orders. So let me go back to find the command. You want your X, which is your number you want to find, your N, which is your total, and P, which is your percent. And then type in false when you want only that one single value. All right, B. No more than 6 in favor. So you do not want to go past 6. So this would mean you want to find the probabilities of all these numbers from probability of 0, probability of 1, and you do not want to go past 6. Probability of 2, all the way, and you stop at the probability of 5. Now you don't have to do each one by hand. Well, if you use Excel, you can use your cells to just find them, and then you can type in equal sum and choose your cells. And then you can highlight your cells, right? If you're using your calculator, you can use binomial CDF. When you use CDF, it counts from 0 to a stopping number. All right, one more thing. With given a probability and a sample size, I can also give you the mean and the standard deviation. And these are the same formulas. Your mean is your average is your n times p, and your standard deviation is the square root of n times p times q. All right, you don't really need a calculator for these problems. I'm sorry, extra technology. Use your calculator. The calculator on your phone will do it. Let's see this example. According to the CTIA, 41% of all households are wireless-only households. A simple sample of 300 households determine the mean and standard deviation of wireless-only households. All right, so our mean, our average, according to our formula that we have here, it would be n times p. So let's let's take a moment to figure out n, our p, and we're going to need q for this one. All right, so n. What is the number of our sample size? 300. Our percent, our p, 41%, so we write 0.41. And our q is just some calculation. 1 minus 0.41. We use our calculator, that's 0.59. All right, our mean is n, and we're going to multiply it times p. What are these numbers? Our n is 300, and our p is 0.41. Cool, multiply them, that's your average. It makes it much easier once you figured out your variables, that when you follow the formula, you have everything written down. All right, lastly, our standard deviation. We take the square root, and our formula above says n times p times q. N is 300, p is 0.41, and q is 0.59. You can get that from our calculator as well. Our answers, if you punch them in correctly, are 123 and 8.51. All right, that's it for this week. We're only going to cover 2 sections. You have an exam to finish, and I think that's fair. All right, if you have any questions, feel free to email me or post them in our discussion board. Thank you.